Hi everyone. Thanks all of you for joining this last meetup of the year here in Cloud Native August. Today I'm going to talk about how to supercharge your platform with Carvel. So let's dive right into the context. We build Cloud Native platforms because we want to enable and support development teams in developing and delivering software solutions so that we can deliver value to our end customers. So we know that we want to focus on the end user experience of the platform. So we carefully design the platform API so to provide several features and functionality to our end users. And then in the back, we have the implementation for all those features, those functionality. And we usually split up the backend in terms of capabilities. We can have different capabilities in our platform backend. For example, certificate management, continuous deployment, load balancing. And today I want to start our journey by focusing on one of these capability and in general, how can we implement and package a capability for being part of a platform. So how many of you are working with Kubernetes? Nice. So I'm going to focus as an example on the continuous deployment capability, but we'll see that the technique we'll look into are actually quite generic. So you can apply to any capability you have. I'm going to use a project called Carvel. It's a CNCF sandbox project for this demonstration. And Carvel is actually a suite of different tools. There are 7 different tools that follow the Linux philosophy, meaning each of these tools does one thing and one thing only. So you can use one of them, 2 of them. You can use a few of them together or together with other tools that you already have in your platform, in your project. So that's the whole philosophy behind Carvel. Today we're going to see a few of them. And they're going to help us doing configuration, deployment, and we'll see a nice few things that we usually need if we're building a platform for production. So to ensure safety and security and predictability in our deployments. So you heard, I'm Thomas Vitale. I work as Systematic. I'm a software engineer and cloud architect. I'm really passionate about anything cloud native and Java related. I combined all these passions of mine and wrote a book recently. It's called Cloud Native Spring in Action. I'm also a big supporter of open source technologies, contribute as much as I can. And one of the projects I contribute to is actually Carvel. So that's why I'm here today, sharing what I learned working with Carvel in the context of platform engineering. So let's start our journey by identifying the upstream dependencies. So I want to focus on building a capability for continuous deployment for a platform. And usually we don't start from scratch. We have a vast cloud native ecosystem of tools. For this example, I'm going to choose Argo CD. So the first thing that we want to do is check how to install this capability. And for Argo specifically, we have these 2 steps described in the documentation. We create a namespace, and then we apply some manifest. Now, we have the possibility to apply Kubernetes manifest directly. Perhaps you're using Helm charts, but in general, we have a problem on how to manage upstream dependencies. If we are building applications, we have package managers, dependency managers to actually handle dependencies in a uniform way. But at this point, when we want to start building a new capability for a platform, we have a wide variety of options, which makes it difficult to handle all these upstream dependencies. It could be plain Kubernetes manifest. It could be files that we fetch from an HTTP endpoint, Git repository, Helm chart. It could be an OCI artifact. So we need a way to fetch that content in a safe way. Of course, I could directly apply the manifest from the internet, but probably I don't want to rely on this GitHub endpoint for several reasons. Perhaps I'm working on a network restricted environment. I don't have access directly to GitHub. Or maybe I want to do some processing before applying this manifest internally. I want to maybe scan this manifest for security using something like Trivy, or maybe I do some policy management with the Caverno CLI. So many times, it's the first step we encounter here is actually download whatever source we need to build our capability locally in our own Git repository in our own organization. And the first tool I'm going to show is called Vendir. It allows to do exactly that. It's based on a configuration where we can specify the source that we want to synchronize. So we have a configuration file where we specify all the contents. In this case, I want to point to the Argo CD Git repository. I specify and what files I want to synchronize on my own repository. and in this case, just the installation manifest. And once I configure that, I can say vendor sync. And then it will synchronize that file locally. And then I have this local folder with the upstream manifest. And this works with different types of sources. So this is the first step in our journey. I need a safe and secure access to the original source for a project. In this case, is Kubernetes manifest. Here it is, the install manifest from Argo CD. That will be our starting point. Same thing will work if you are using a Helm chart or an OCI artifact as the foundation. All right, that was step one. So with vendor, we can synchronize any upstream dependencies. It doesn't have to be Kubernetes related. You can actually use it in your workflows for whatever file. It's basically a synchronization mechanism. And the interesting thing is that it locks those dependencies for repeatability. And it supports various sources. So if I check what I obtained in the code, I get a log file where it resolves the version to the commit digest. Because also I don't want to use tags, I don't want to use versions because they are mutable. I want to use a digest because that's an immutable, and it will point directly to the specific commit. So I'm sure that from this point on, I'm always working with the same manifest. But if I use the tag or a version directly, I'm not sure about that. All right. Now, the next step that we saw here was, once we get the manifest, is applying the manifest. So let's talk about deployments. And you might think that might be perhaps a very basic thing. So what's more to say about deployments? We do kube control apply, and that's it. Let's try that. So I have a namespace manifest, since I have to create this Argo CD manifest myself, since Argo doesn't provide that as part of their scripts, but it expects one. And I also created a limit range for this manifest, just to set up some CPU limits to 50M. So now what I can do is saying kube control apply. And now I want to ask you, do you think this command will succeed? Raise your hand if you think so. No? Let's see. OK, it failed. So why did it fail? Because kube control goes alphabetically if I point to a folder. So it tries to create the limit range first. But the limit range expects the namespace. And the namespace is not being created yet. That doesn't work. So in order to fix that, we come up with any sort of tricks, like using these numbers at the beginning of the file. That's something very common in a lot of different cloud-native projects. But that's really not that nice. I mean, on top of having to use YAML, also having to care about this, maybe I want something else. So let me delete those. And I have to point to the same manifest to delete that. Let's remember that. And now I'm going to use a different tool called cup that comes from Carvel. So I can say cup deploy. I give it a name, Argo setup, and then I point to those files. Now, cup is quite smart because it knows that namespaces are supposed to be created before resources that go into those namespaces. So you can see that it sort and order resources automatically for me. So now it's reconciling, and it's waiting for everything to be actually up and running. So unlike kube control, it waits for the health of the resources you're creating, which is quite convenient because if you're using a CLI, probably you want to know when it's done, because otherwise you would be using GitOps in production. But if I'm using the CLI, probably I'm interested to know, and I don't want to run all those watch commands waiting for the pods to be done. And cup can wait for that. All right, next step. We got our manifest synchronized from upstream. So I can go with kube control again and apply the manifest. So I have it in the upstream folder, Argo CD namespace. All right. And this manifest is what we call the desired state, right? So I have the manifest down here. This is the desired state. We also call it the single source of truth. Now, it's a bold statement saying that this is the single source of truth, though. I mean, it's a huge responsibility being the single source of truth, and I'm not sure that is true. So We're engineers, so let's design an experiment and verify if the hypothesis is correct. I can see that we have a secret in the manifest. It's called Argo CD secret, and it's empty. So I expect my desired state to match the actual state, because this is the single source of truth, right? Or at least that's what the hypothesis is. And now, I think I have it open, yes. So if we check the Argo CD namespace and check the secrets, is it deployed yet? Let's check in the Argo CD namespace. OK, everything is running. Nice. All right. Let me start that again. Localhost, and what's the number? So this is a convenient tool, which is actually deprecated. It's not actively maintained anymore, but I like it so much that I keep using it, but it's my fault if it doesn't work. All right, we got it. So we can check the secret. We get the Argo CD secret, and we can see that it's not empty. There are 5 credentials. That's because Argo CD at runtime, it will create those secrets. But we know about the reconciliation loop within Kubernetes. So what happens if I apply the manifest again? I expect the state to match what is in my Git manifest, right? So I'll apply the manifest again. I'll refresh just to be sure, and the credentials are still there. So I don't think this is the source of truth, right? This is empty, but it's not empty in the cluster. Let's try something else. I'm going to go and check one of the deployments from Argo, in particular the Argo CD Redis. And if we check the manifest, we can see that the pod in this deployment has a security context configured. And we can see that there is this option here, run as non-root true. So the admission controller, when I try to deploy this, will verify that all the containers in this pod will run as non-root. Otherwise, it will block the deployment. And all the containers will inherit this setting. So we can see that the Argo CD container doesn't have that setting specifically, so it's inherited from the pod. What happens if I add that configuration explicitly on the Redis container? And I say run as non-root false, so that the admission controller will not check for the non-root user. I'll update it. The update, of course, is correct. Now I want to apply the manifest one more time. So what do you think just happened now? Is my setting removed? Raise your hand if you think so. Let's verify that. Refresh the page. And if we check the security context for the Redis container, it's still there. So we need to be careful when we talk about single source of truth, because clearly we are not having what we desire. What's in our Git repository is not what's in the cluster. And this can be a problem, especially if you work in highly regulated industries and you want to really be in control of what is happening in your cluster. Because now I mentioned the example with security context, but it could be any kind of option. And the problem here is that there wasn't a key value pair there to begin with. So when I do kube control apply, that value is not considered in the diff. All right, let's see what we can do. I'm going to delete the deployment, upstream install in the Argo CD namespace, and now I'm using Carvel cap. Let's give it a second. And now I'm going to do the deployment with cap deploy. So I give it a name, Argo CD. I point to the same manifest, Argo CD namespace. So it will make sure that all custom resource definitions are created before custom resources, that all namespaces are created before the namespace scoped resources, and it will wait until Argo CD is fully reconciled, which is quite convenient. But I think we can already see that if we check the secrets, once again, we have the credentials, because cup will deploy Argo CD, and then the Argo CD controller at runtime, at first deployment, creates the secrets. Now, what happens if I do a cup deploy operation again? Let's see. So it detects a change. OK, so that's a diversion from the desired state. So it will, if I say yes, it will try to update the secret to match the state on the repository. Now, you might think that that's a bit annoying, because now Argo CD will break, because without that secret, it will not work anymore. But if you think about it, it's actually good that we know what is going on, if there's any drift. If I try again adding the run as non-root option, that will be removed as well. So if we want to allow certain changes, like in this case, I won't allow the secret to be changed at runtime, I need to be explicit. I need to tell cup that that is OK. And I add that information in my Git repo, and at that point, I get the full desired state. So I can provide a configuration like this. They are called rebase rules. I point to a secret, the secret called Argo CD secret in the Argo CD namespace, and I'm telling Argo CD, Carvel cup to check the data inside the secret. I want cup to always prioritize what's coming new from the manifest. But if nothing is there, like in this case, I want to keep the existing values. And now this configuration might seem a bit too much, considering that in kubectl apply, we don't have to care about this. But now, if you look at the Git repo, you can see what's actually going to happen in the cluster. So you are fully in control of what's going on there. All right. And one more thing. Cup also groups all resources into applications. So you can say cup inspect Argo CD. And then you can see all the resources that belong to Argo CD. And if I don't want, or if I want to uninstall Argo CD now, I can simply say cup delete and give it a name, -a Argo CD. And I don't have to point to the original manifest. So it keeps track on the cluster of all the related resources. And now it's undeployed. All right. So that was the second step about deployments. So we can see that cup is not really a drop-in replacement for kubectl apply. So if you try that, just be careful. But it groups resources as applications, which is quite nice. It waits for the reconciliation. So I don't know if you ever had the situation where you needed to script some deployments from the CLI, and then you have all these bash scripts with if and for loop waiting for all the pod to wait, like replacing kubectl there with cup. Then I just go from 100 lines of a bash script to maybe 10 lines. So that's quite convenient. You can achieve predictable and safe deployments. You know what's going to happen. It orders resources based on dependencies, so you don't need to worry about having those weird prefixes on all your resources. And finally, it keeps track of the deployment history, all on cluster. And by the way, this is client only, so I haven't installed anything on the cluster for this to work. So you can use the CLI, and it will just work. There's no server-side component. All right, let's talk about configuration, and about, in particular, templates versus overlays. So now I'm curious. Do you prefer templates? Raise your hand if you do, like with patches and overlays. OK, bit unsure? OK. But there's usually this fight against, like, oh, I want to do patching or I want to do templating. Like, do I want to use customize for overlays or do I want to use Helm for templating? And my comment usually is, why not both? I mean, we can't just do with one. So I want to do something else. I want to be able to use both. And YTT in Carvel allows me to do that because it provides configuration capabilities via templates. And it also provides configuration via overlays. It's all based on Starlark, which is a Python dialect. And the good thing is that it's structure-oriented. So it works with YAML, and all your templated or overlaid files are all valid YAML. So you don't need to worry about all the white spaces and indentation like it happens with Go templating in Helm. So everything is pure YAML. YTT understands YAML. You can validate the schema, and it works even outside Kubernetes. It's just YAML, pure YAML. I use it for my GitHub Actions workflows. You can use it for Ansible, for GitLab CI pipelines, for example. So it's quite convenient. Let me show you how it works. So this is an example of a template. I have my config map. What I need to do, so you can see it's a YAML file. I load the module from YTT that provides access to the configurable data values. And then I use this syntax to fetch one of the values, the value called conference name. And this is a YAML file. So if I have some Kubernetes support from the IDE, and for example, I remove the name, then I get an error because the name is required in a Kubernetes resource. So it's quite convenient to be able to work with standard YAML and keep the file as a standard YAML file. And then we have overlays capabilities. For example, I want to define the service type for Argo CD, if it's a cluster IP or load balancer. So I import both the data module, because I want to configure that from the outside, and then the overlay module. And then with the overlay, I can identify the service named Argo CD server. And for that, I can apply the overlays with the type. So I have the combination of the templating part here with the overlay part. And I'm also specifying that this type is usually not there in Argo CD because it's just using the default value, cluster IP. So it's fine that it's missing. I want to add it and be explicit about it. And finally, I have a schema. The schema, I can just put some default values, or I can even use the validation capabilities of YTT. So in this case, I'm adding some description and some validation rule for the service type. And this will be verified at runtime. Let's give it a try. I can say YTT and point to that folder. And what I can do is maybe let's put the output in a YAML file. So this is YAML in, YAML out. So we have the render file. If I search for the conference, I can see that we have the default value, add name here. So now I can provide the values YAML file, just like we would do with the Helm. Or I can actually pass it from the CLI. So I can say data value conference equal cloud native OS. And now that's wrong. So I can see the validation in action because the field is called conference name. So I get a nice hint saying, hey, did you mean conference name? Yes, I did. So let's fix that. Conference name. And then we get the manifest correctly. There it is. And now I can pipe this with cup. So I mentioned at the beginning this Linux philosophy. I can pipe together all these tools. So I can say YDT command for the configuration. Then I can pipe it to cup deploy Argo CD and then point to the input of or the output of YTT. So you can pipe them together. Or you can use it with kube control still. Like it's just YAML in, YAML out. So it's quite flexible. OK, let's keep talking about configuration because I think we have another problem in here. So we were talking about Redis earlier. So all the images used by Argo CD points to images with a certain tag. But just like with the git commit that I mentioned earlier, these tags are not really safe to use. We want to resolve these image tags to digest. That's immutable. Now, there are different ways of doing that. A common way is actually having some policy in the cluster that at admission time or deployment time, then it resolves those tags. But that's not safe, because if you have multiple clusters and you deploy the same thing at different times, you might end up having different versions in the different clusters, because the resolution is deferred until the last minute. Instead, I want to anticipate the resolution at the configuration time so that it's always the same digest that I'm using when deploying. And I can do that with another tool called kbuild. So I can say kbuild. Once again, I point to the configuration file and update the render YAML file. Let's see what happens. So if we check once again Redis, now the deployment for Redis will have an annotation keeping track of the original mapping. So we want to know what was the original image, of course. We don't want to miss that connection. But then if we look at the image, it's now resolved to the specific digest. I can also lock those dependencies. So I can add to the command that I want to get the lock output, output.yaml. And now if I check that file, it's a really small screen. There it is. So we have also the list of all the images used in this package, which is quite convenient if you want to do vulnerability scanning beforehand, you want to generate a software bill of materials, because then you know exactly what's in the package. We don't want to just install a YAML file from the internet. We want to be in control. You can verify all the signatures, for example, because Argo CD signs all the images. But in this case, we can see that there's also 2 images that don't come from the Argo project. So maybe the Argo image is safe. How about the other ones? They're not signed. So there's different supply chain security considerations to do, and having this kind of visibility can help with that. And then I can pipe all together. So I can say YTT, and then I can pipe it to kbuild, and then pipe it to cup. Or I can use it in isolation or together with other tools, with customize, with kube control. All right. So with kbuild, just to sum up, we can resolve the image references. We can lock the references for repeatability. And kbuild actually has different functionality for orchestrating the image building, but I'm not going to show you that. But you can use different tools like Docker files, BuildKit, BuildPacks, or Co to build images, so you can orchestrate it in one configuration file, should you have different projects you want to build all at once. And now the next step is actually the important part, because I've been working with a lot of files right now, but what if you want to deploy my own distribution of Argo CD? I need to bundle all these configuration files into an artifact that then I can deliver to you, and then you can use in your own platform. And a way of doing that is actually using a standard format, OCI, that we use for container images for applications, but we can use it for configuration. And we can do that with image package. So if I go back, now that I have all these files together, I can say image package, push, and push to my own container registry on GitHub. It was 293, I think, something like that. Yeah. Let's see if I remember this. No, that was it. Oh, yes, and I have to point to the folder, of course. So now it's taking all these files, and they are all bundled together in an OCI artifact. And if I check my GitHub container registry, I'll find the container image there. There it is. So now we can take this image and deploy it, or at least pull it down, and then we actually need to go through a few steps. But before doing that, I want to show you another thing, because I can pull that down now. I can say image package pull and get the folder. But what I said at the beginning is still valid. Like, I probably don't want to depend on things from the internet, even if it's my own container registry now in the public internet. I might work with air-gapped environments, for example. So how cool would it be if I could automatically get my own configuration plus all the images automatically exported to a private registry? Well, I can actually do that, because with image package, I can say image package copy. And then I can copy from my public registry or from someone else's registry to my own private registry. Now I'm still using GitHub Container Registry, but it's under a new project called air-gapped. And automatically, using kbuild, it will resolve all the images. So it won't just copy my own OCI artifact, but it will copy all the images used from my manifest, so all the Argo CD images, and it will update all the references in my manifest. So you can see that it's exporting all the images. So with one command, I get now a full package available in my private registry in my company. And if I don't have access from the same machine both to the public registry and to a private registry, like through some kind of jump host, I can export it as a tarball and then upload it. So we get this bundle configuration as OCI artifacts, support for air-gapped environments, and we get this unified way of distributing both configuration and configuration. And now the final part is around package management. Because if you take this OCI artifact yourself now, you can pull it down on your computer, but you still have to go through 3 stages. The first stage, you have to fetch it. So you can fetch it explicitly from my container registry, or you can use Vendir, just like we saw before. Then you would have to go through those transformation steps using YTT, kbuild. Maybe you want to use Helm template, or Q, or SOPs for resolving some secrets. So we have different steps in there for transforming our manifest, and finally the deployment. And of course, we don't want to do this manually. So now the final step in this journey for packaging and distributing capabilities is getting this artifact that controls both configuration and applications into something that is Kubernetes native, a package concept within Kubernetes. And that's what Kub controller from Carvel does. So we get a custom resource definition that is not appearing on screen. I wonder if it's just like the other slide, you know? Yes, it's not. OK, interesting. So apparently we have some slides that don't want to show. Yes, OK. So what if yeah, now it worked. So we get a package custom resource with the 3 stages I've just mentioned. The first stage is the fetch stage. The second, transform, where we use YTT and kbuild. And the final one is deploy. And I think I need to do this again. Yeah, let's keep it like that. Not working correctly. Fine. So in here, we can put together all these Carvel tools, but you can also add extra tools. So in the transform step, I can use Helm template. If I'm using Helm, I can use Q, I can use SOPs. And right now, the Carvel community and the operator framework communities actually are collaborating together to bring support for the operator lifecycle management from packages in Carvel. So that's also a nice way to see different projects, different communities getting together to integrate more tightly their projects. All right, so we got these packages. That was the final step. With Kub controller, we can achieve this continuous deployment. It's actually working via GitOps. It's a custom resource, so I can deploy it any way I want to. I get this Kubernetes native package management, automated workflow to build packages. There's a CLI that immediately can get you up and running with the package, also including the release lifecycle. You can then package and distribute platforms, because now I have an OCI artifact for my continuous deployment capability with Argo CD. I can build these packages for each of my project or capabilities in the platform. And then I can use a trick. It's called the meta package pattern, where I take all these custom resources, declaring my packages, and I put them in a separate package that it will be my platform. So I have my platform packaged as an OCI artifact. I can install it with one command. I can move it around in a private registry or in an air-gapped environment with one command, because it's a single entry point where I get access to all the capabilities and all the both configuration and images. And finally, as I said, this works not just for the Carvel tools, but you can integrate multiple tools as well. So I want to show you how it works. I have it here. Well, I can show you from here. So we have 3 steps. And nice that this slide doesn't work here either. But we have a platform in 3 steps. I can deploy Kub controller on my cluster. I add a package repository, which is a Carvel concept where I can basically provide the metadata about all the packages that I'm allowed to install, because I want to be in control of what is allowed to be installable inside the cluster. And finally, I can install the platform with a kcontrol CLI that comes with the project. And since the slide doesn't work, I'll show you from here. So I can say kcontrol package install. I point to my package that represents my platform. I'm configuring something for working on my local Kubernetes cluster, and there it is. So if I check all the packages installed now, I can see that I have maybe like this, almost, yes. We can see all the packages installed. I have Cert Manager, Contour, Caverno, and they're all reconciled. So there's a GitOps workflow that is used to keep all these packages in sync. And all I did was installing the platform package. All the others come with the main package. All right. So that was a very quick journey across different tools in Carvel and how it can help with building this platform. The idea is splitting the backend into capabilities. Then we can package each capability using this concept from Carvel. It's a standard OCI artifact. I can push it on my public container registry. I can move it to a private registry with one command and resolving all the images. And I get this concept of safe deployments thanks to CUP. So I'm always in control of what I'm deploying. I want to mention 3 projects right now in the CNCF space. We have a TAG, App Delivery. TAG is a technical advisory group in the CNCF, which has been working on different things related to platforms and artifacts. One thing was the white paper about platforms. I was also part of the group that wrote this. We announced it at KubeCon Amsterdam. So if you're interested in platforms, what they are, capabilities, platform teams, you can check it out. And then there was also a follow-up work from the same team. It's a platform engineering maturity model. So if in your organization you're building platforms or you're thinking about building platforms, this maturity model can help you guide and organize the journey within your organization. And finally, since I talk about artifacts, there's also a dedicated artifacts working group with representatives from different projects, like from Helm, from the operator framework, from Carvel, around how to better use OCI as the unified standard for basically dealing with anything related to configuration in the Kubernetes ecosystem, which is also quite interesting. I'll leave you with some resources. I have a GitHub repository with some packages that I maintain, so if you're interested, we can talk about more later. But thank you very much for joining, and have a good rest of the day. Yeah, bye.
We have plenty of time for questions, so if you have any questions, feel free to raise your hand and ask Thomas.
Yes?
Are there any advantages in using it together with Flux?
So I repeat the question maybe for the microphone.
Yeah,
so is there any advantage of using with Flux? So I typically use Carvel together with Flux. Now it's kind of like a chicken and egg problem. What do you install first? Do you install Flux and then install Carvel and then install the full platform via the package mechanism, or do you install Carvel, which also installs Flux? So I went with having as my only dependency on a plain cluster, installing CUP controller, and then I have my platform package that also installs Flux. So you probably saw that I have Flux installed there. But yeah, you can do the opposite. But I have Flux. So I use Carvel CUP controller mainly for package management. So the whole GitOps workflows, but specifically for packages. Then I can still use Flux for dealing with all of the applications and expose or use Flux to let maybe the application teams publish some application manifest and then reconcile that. So they work together, or even with Argo CD. Yeah.
Any other questions?
Yes?
Are you using any of these tools in your everyday work at Systematic?
No, not in my daily job. Like I work with this on my side projects, and actually I build a platform that I use a lot. When I give presentations, I need some environments with all these tools. So now, like with one command, every time I have a presentation, very easily I can spin up a full environment. So I started from there, and then I started actually maintaining all these packages. I have a project on GitHub. It's called Cadras, with any kind of package that I need. And then I use it both as my, let's say, presentation environment or research environment to research other tools, or in general for my side projects. Yeah. Yes?
I was interested in the namespace dependencies,
Yes.
where you actually have the order of deployment. How smart is that tool, or can I reconfigure it if I need to do that?
Yeah, so the question was about the namespace and how smart is CUP in sorting resources. So there's no, I can probably go into the website because there's no magic. So there is, like Carvel CUP has configurations for 2 main behaviors. One is the rebasing that I showed earlier about secrets. So you are explicitly saying what you want to keep that is changed in the cluster, when you do the reconciliation. And the other one is how to order resources. And there are order rules. So CUP comes with default order rules that you can definitely override. But you can see from the CLI, I think it's CUP, I never remember the command. Let's see, CUP deploy config, where you can see all the rules that are applied. So now I'm not going into the syntax, but it's any kind of matchers and rule. So in here, there's rules about, for example, custom resource definitions are always applied before custom resources, or rules to ignore if the number of replicas on a deployment is changed, if it's caused by a horizontal pod autoscaler. That's another source of drift between desired state and actual state. So there are different rules in here that you can check. You can override them or add your own if you have specific needs. So if you have certain deployments where maybe you want to run some database migrations before deploying an application, you can use the same mechanism to order resources that way. So default are available. You can check them. You can override them and even add your own rules.
I like that. It's more idiot-proof.
Yes, and I like that it's available conveniently from the CLI. I don't have to go to the GitHub project and check the code. Like, it's very transparent. Like, this is what it's doing. And so I'm aware of what it's doing, and then I act accordingly. Yeah.
So it's just on the surface, it's magic, and underneath we can actually see what it's doing.
Yes.
All right.
Yes?
You talked about a source of truth, but can you use CUP to pull the changed values into Git? If you can follow, like the secret you showed.
So the question is about the single source of truth, and if you can move like things from the cluster to the Git repository. No, it can't do that. But I would say that, I mean, it's a very, I don't know, debatable statement, but for me, the single source of truth is always the cluster. Yeah. Because the cluster is the, yeah, you never know what's happening. Maybe the reconciliation loop from whatever GitOps controller you're using stops working, and then you get the configuration drift. So I would say that the secrets, for example, I don't want them in the Git, right? So it makes sense that it's different from the Git repository. It's just that I want to be aware and in control. So I want to be explicitly allowing that secrets can be empty in my Git repository and then populated at runtime, and even be specific about what keys maybe could be there, just to avoid some malicious actor just trying to change things there. So it's it's about predictability, basically. So it's totally fine that the secrets, or it's actually a good idea that secrets are not in Git. But
This is a bad example.
yes, yeah. Yeah, any more questions?
I'm not so much knowledgeable about the OC layers, but if you are making these packages, if you start, does it optimize away duplications in the registry, so that you avoid that you had people that started uploading multiple packages with the same stuff in, so you just have a lot of duplication, or whether the registry can optimize out of that because it's layers?
Yeah, so the question is about the layering in the image. So for the specific case of configuration, it's only one layer, so you don't get the different the split into different layers. For configuration files, I would say that's not a big problem because it's small.
Bundling these different images.
Yeah, so when doing the bundling, actually, you still you have different artifacts. So in the case of the air-gapped environment from before, so this was the original one. This is just okay. Okay, it's working now. Yes, so this one is the first example with just the configuration bundle. You can see it's one artifact. In the other case, for the air-gapped scenario, I actually get different artifacts. So each image referenced actually is its own artifact, where then we can take advantage of the layering possibility, like the Argo CD image, the Redis image. But yeah, for the configuration artifact by itself, it's one layer. And the layering capability and metadata and how to define that is actually one of the focus points of the artifacts working group in the TagApp delivery. They're working a lot around that, just to optimize and see what else can we add to the standard in order to manage even better having this type of artifacts also in an OCI spec, not just applications. Yeah.
One last question?
So we'll just close saying that if you'd like to know more about Carvel, you can join on the Slack channel, on the Kubernetes Slack. The maintainers are really, really awesome. Like if you ask questions within a few hours, you always get a response. They are fantastic, and there's always possibility to contribute. Right now we are looking into, for example, the collaboration with the operator framework community, just to bring together the two projects. And we're looking into some supply chain security stuff, so to make sure that all our Carvel artifacts are signed, there's provenance attestation, and we're looking into making it even more extensible, so that you can include your tools in that transform stage in Cap Controller. So if you want to add customize or whatever tool you have, then you have an easier way to integrate. Right now, there's extensibility, but it's it can be improved, so we're working on that.
All right. Thank you so much, Thomas. Let's give Thomas a big round of applause.
Yes, thank you.